Hello. In this short video, we're going to show you how to make an accurate body composition measurement using the BodyMetrix. The first thing to do is to pick the formula. Generally, a three-site formula is a good formula, and that's what we'll demonstrate in this demo. When you're ready to make the measurement, apply a bit of gel to the head of the BodyMetrix device, and for a single measurement, typically a dime size volume of gel is enough. Once you've done that, select the point you're going to measure. Then click on single point. Now to make the measurement, the first thing we need to do is get a very thin layer of gel spread on the skin. So to do that, we put the device on the skin and move it up and down as shown. Now to make the measurement, press the button on the device and then slide the device up and down a little bit, again as shown, while keeping in contact with the skin. This technique is called averaging. So let me repeat that again one more time. Again, put the device on the skin, slide it up and down several times, and you're moving it about 1/4 of an inch on either side of the measurement point. That gives you a signal, as shown here, with very kind of well-defined characteristic peaks. The first peak generally is the fat muscle interface. Second peak in this case is actually fascia layer within the muscle. Now what we're going to do is we're going to repeat the measurement, but this time we're not going to average. Okay? In this case, what we're going to do is just put the device on the spot, but in this case, not slide the device along. Literally just press the device for a fraction of a second and let go. The resulting measurement data shows characteristics of an average signal. You see many thin peaks within the graph, again characteristic of fine tissue structure. Keep in mind that the BodyMetrix transmits a narrow beam of ultrasound and detects tissue structure along that beam. Now we'll do this signal with averaging. When you average it, the fine structure disappears, and what you're left with generally is kind of the big interfaces, the fat muscle interface, for example, the bone muscle interface. So let's repeat this again, and this time using the averaging, and look again at the graph at exactly what happens and how the difference is. With averaging, you can see how the ultrasound signal structure has gone from many thin peaks to a few isolated peaks. The software is telling us to do it a third time, and the reason it's asking us to do that is because the two measurements differed by more than 10%. So let me repeat it, and again I'll do the averaging technique so that we eliminate all the fine structure. Okay, and there we go. There's the measurement, about 6.5 millimeters on the thigh. Repeat measurement, no, and we're done. Okay, so now we would go to the next point. Okay, in this case we'll do the chest. Again, just as before, apply some gel to the device. Put the device on the spot, press the button, and again, the averaging technique. Repeat the measurement. There it is. And since in this case the measurement's agreed by better than 10%, you're done. Okay, it doesn't ask you to do the measurement a third time. So we click no for repeat. Now we're going to do the waist measurement. Okay, the waist measurement is just an inch to the right of the belly button. And again, we always do the averaging technique. In this case, we actually slide the device left-right on the skin. So let me just see. Press the button, slide the device back and forth. There's the characteristic peak. Repeat the measurement. And there it is. 23.6 millimeters. Repeat the measurement. No, we don't have to do that. But this graph illustrates a very important thing about the waist measurement. True fat muscle interface is not necessarily the first peak. In order to get correct and accurate measurement, it's necessary to select the correct athletic type. BodyView has 3 athletic types. Elite, which would be generally appropriate for individuals with low body fat. Generally, they have good muscle definition and exercise regularly. They can be marathon runners or bodybuilders. This definitely includes individuals with six-pack abs. Non-athletic are individuals that are clearly overweight and obese. The final category, athletic, covers pretty much everyone else. It's important to note the athletic type does not explicitly enter into the calculations of body fat. The athletic typing is in fact used by our software to correctly interpret the ultrasound signal and correctly identify the true fat muscle interface. What you notice from this series of measurements that the thigh and chest measurement does not change as you change the athletic typing. The only one that does change is the waist, and what you see on the waist, the difference between if you selected an elite or athletic or non-athletic, is the waist point for elite is considered to be the first strong signal at 8.2 millimeters, whereas for an athletic or non-athletic individual, the software makes a determination the most likely fat muscle interface is the one at 24 millimeters, and in fact that the peak at 8 millimeters is a fascia layer that's within the fat. And this is what you typically see for the waist measurements. People that are elite, the fascia layer and the fat muscle interface tend to merge together to form one layer. But as fat thickness in the waist grows, these two layers separate, and then you get these two compartments. And what people sometimes call this is the superficial adipose tissue. There's a layer of fat between the skin and this first fascia layer. And what they call the deep adipose tissue, or deeper adipose tissue, is the one between the fascia and the muscle. Now, one of the important things that you can do is that you can, in fact, always override the software. So, for example, let's consider that you've just made a measurement and you had set the athletic type to elite, and what you see that is on the software is that the software has picked the 8 millimeter peak. Okay. Now, 8 millimeters is about 1/3 of an inch, and the other peak that you see on the graph is the one at 24 millimeters, which is close to an inch. Now, it's in most cases very, very easy to determine whether the fat layer in your waist is 1/4 of an inch or it's an inch of fat. The two are very, very different. 1/4 of an inch is kind of a fairly thinner layer, and you can poke a little bit, but it's not a significant, it's not a fold of fat. And so at 24 millimeters, you're trying to see kind of a fold of fat. It's something you can literally grab, and it's a significant fat layer. Now, if you've actually accidentally put the athletic type as elite and you look at this signal and the software has picked 8 millimeter, you can step in and click at the second peak, as I'll do now, okay, and accept this change and override the peak. And what this does is, even for an elite, for this typing, it will force the software to use the 24.6 or the second peak as a true fat muscle interface. So now you get the actual measurement, the 24.7. Now notice that if I change the athletic typing now, the thickness on the waist is always the same. It's really overridden the measurement, the specific measurement for the elite type. Now, when you're making measurements with clients and you're creating client profiles, you will actually pick the athletic typing when you create the client profile. So at that point, you want to make sure you pick the correct athletic type for the individual. But keep in mind that you can always override the automatic peak detection algorithm within the software, as we just demonstrated. Now what we're going to show you is how to actually collect an image or a tissue cross-sectional picture. So for example, in this particular case, we're going to do a bicep. So let's select the bicep. And now what we'll do is we put gel on the device, and similar to before, but in this case you put more like a 1/4 size of gel on the actual head of the device. So once you've done that, you apply the gel, you put the device on the bicep and slide it back and forth over the bicep a few times. Okay, and what you're doing there is making a nice slippery track of gel so that it's easy to move the device along the skin when you're making the measurement. So now when you're ready to do it, okay, now you've made the track, okay, move the device back up to the top of the bicep, press the button, and now start sliding the device along the skin down towards the bottom of the bicep. And as you do that, you see this picture that forms on the screen. So what this picture now shows is a cross-sectional picture through the bicep. The left side of the image is kind of the upper above the midpoint of the bicep, and down here at the right side of the image, it's very, very close to the elbow joint. So what you're seeing in the way to interpret these images is where you see white or light blue signal, it's indicative of a strong ultrasound echo or reflection. You get strong ultrasound echoes or reflections at interfaces. So for example, this first line right here is in fact the fat muscle interface. So for this specific individual, they have approximately about 3.9 millimeters of fat. That's between the skin and the muscle. You can see that this fat layer kind of gets thinner as you move towards the elbow. So you start off potentially at about 4.1 millimeters and you get down to about 2.5 or 2.3 as you get closer to the elbow. Now what you're also seeing in this image, you see a region right here. Okay, and this is in fact kind of the first muscle group in your bicep. It's a darker area. Then you get the second muscle group, which is down here. And then the final, this white band that you see, and it's right down here, this white band is in fact the bone. So this is the muscle-bone interface. And the total muscle thickness that you generally consider would be from the fat muscle interface down to the bone, which is about 40 millimeters. And one of the things you can do with these images, you can literally track interfaces. So if I come up here and I click on a line, the software will try to automatically track that interface for you. Now you can come in and literally put tag points on that forces the software to track a line if you're not totally satisfied with the way it tracked it. You stop tracking, you can track a secondary interface. So let's say right here, for example, the second layer. Okay, so that gives you thickness between the two different tracks. Let's do another scan now. Let's do a thigh because it gives you a different kind of image. So as we did for the bicep scan, we apply about 1/4 volume of gel onto the face of the BodyMetrix, put it on the thigh above the midpoint, and then slide it down towards the knee without pressing the button and just spread the gel, and then go back and forth a couple times. And you know you've got a good track when literally it's very, very simple or very easy to slide the device back and forth without it sticking. So now let's do a scan. So move the device back up to the top, press the button, and slowly slide it down towards the kneecap, and you'll see the picture writing up just as it is here. And what you're seeing in this particular case, there's again that first characteristic feature was the fat muscle interface. And so in this particular case, this individual has about 6.7, 6.9 millimeters of fat. As you get towards the knee, you get a thicker layer here. You're going approximately up to about 8 millimeters of fat. Now the band at the bottom right here is the bone. So again, where you're looking in terms of muscle thickness, you're going from the fat muscle interface down to the bone, is about 47 millimeters. So you can save these images so that later on you can actually compare them. Okay, so on the compare window, you can actually compare different images. So in this particular case, we show the thigh image, and we're also showing the bicep image. You can click on the show tracks to eliminate the tracks if you'd like. So there you go. In this short video, we've shown you how to go from So there you go. In the compare window, you can actually see the two different cross-sectional pictures that we took. And this in the future gives you the ability to compare specific target areas, thighs, bicep, etc., waist, and you can literally compare the cross-sectional pictures from week to week, month to month to see change in evolution. So you can click on the show tracks here to eliminate tracks if you want to do that. So this short video illustrates how to make accurate measurements with the BodyMetrix system and also how to do cross-sectional pictures. Thank you.